So this is the panel discussion for Ask Me Anything about microservices and also service mesh. If you have a question, it would be great if you can come to the front so that I can easily hand the microphone to you. So I'm going to get started by introduce myself first. So my name is Lin Sang. I work on the Istio project. I'm a maintainer on the project. I'm also serve on the technical oversight committee. I'm the new release manager for 1.2 release. And also I work for IBM. And along with me, we have 4 great panelists. So the first one is Louis. Louis Ryan. He's a principal engineer at Google. I would call Louis is also a co-creator of the Istio project. Back then at KubeCon in Seattle about 3 years ago, that's when Istio was born.
That sounds about right.
Okay, great. The next one is William. So William Morgan is the co-founder and CEO of Buoyant, which is also the creator of LinkerD, the other service mesh project out there. Prior to Buoyant, he was an infrastructure engineer at Twitter, where he helped move Twitter from monolithic to microservices. The very next person I'd like to introduce is Jason McGee. Jason is the VP and IBM Fellow for the IBM Cloud Developer Services, owning Kubernetes services, function services. I think I lose track of all the services Jason owns. Jason is also a co-creator of Istio. And one thing that Jason is very special to me is Jason has been a mentor for me and have me working on containers and Istio, else I probably wouldn't be here today. The very last person, but not the least, I would like to introduce is Zack Butcher. So to me, Zack is a moving target. I could never keep track of him. I remember when I met him, he was working on Mixer. He was introducing Mixer adapter to everybody. And then he moved to work on Pilot, networking component of Istio. And then now he's working as a founding engineer at Tetrate. So not sure where you are going to be next, but very exciting to have all of you be on the panel. So the way we're going to run this panel is I'm going to get started with a few questions. And then after that, I'd like to have you guys engage, because this panel is really for you, to allow you guys to bring the questions so we can ask the panelists. So the first question I would like to kick started is, why do we need a service mesh? With that, I'd like to invite the panelists to jump in.
Why do we need a service mesh, guys? Obviously, I think the service mesh has come out of a variety of iterations of what people have been doing in the networking layer for a number of years. Like, I would imagine most people here had probably been using something roughly termed an API gateway, right, for a long time, and also using API gateways not just for kind of traffic coming in from outside your network, but also for things moving around inside the network. So, and people used API gateways because they wanted to apply policies, or they have other types of kind of organizational administrative control over the traffic flowing around in their network. And they wanted that at a higher level than they were necessarily getting from kind of the L4 networking low-level bits. So service mesh is kind of a natural extrapolation of that kind of dimension of control, commingled with a variety of other features to help people solve security problems, load balancing problems, traffic management problems in a way that's more inherently scalable than a big centralized proxy, which is what API management has traditionally been.
I would just add to that, I think in the container Kubernetes space, we're in the midst of this kind of general transition to a more application-oriented version of IT, where we specify apps and policies around applications. And we're also all trying to adopt these kind of microservice architectures, which are basically a network-connected set of services. And so I think there was a gap in how do we apply those same ideas, that same kind of policy-based, application-centric, policy-based model to the network interactions between services. And that's, I think, at its foundation, what service meshes are trying to do.
So I guess for me, I come at it from a slightly different angle because my background was at Twitter, which did not have a whole lot of like security policy kind of things to it. Mostly Twitter was just trying to stay up the entire time. So a lot of the focus of LinkerD, especially early on, was less on the security side and more on the reliability side, and getting deep into things like, well, how are we going to do retries, and how are we going to do request balancing, and how are we going to deal with the fact that under a crazy load all these things tend to die in all sorts of horrible ways, and we need to have these mechanisms for preventing that. Over time, that's shifted. Certainly, if you look at kind of the modern incarnation of LinkerD, it doesn't really share any code with what we were doing at Twitter, and we have things like Docker and Kubernetes that Twitter didn't have. So the kind of core ideas are there, but I think the thing that we see with LinkerD especially is that it's less about kind of introducing a new set of functionality, and it's more about shifting where that functionality is located. So, things like, to go back to the Twitter example, we had all this stuff in client libraries, and we did very sophisticated load balancing and things, in part because, we were built on the JVM, and there was the GC, and like things were always doing the code was always doing something horrible that you didn't want it to do, and you had to kind of deal with it at the load balancing level. Now with LinkerD, I think a lot of the value that we see is not in reinventing that stuff, but in moving it down to the platform layer and out of the application layer, where it kind of fits more naturally for a couple of reasons. And that, I think, is a lot of, that's what I think the core value has been, because it allows a platform team, and the platform owners and the same folks who kind of have ownership of Kubernetes and are building this internal platform for the rest of their company, to have control over things that are kind of independent of business logic.
That's a very interesting perspective. Zach, do you want?
No, I don't have anything to add.
Cool.
I think they
awesome.
nailed it. Yeah.
Yeah, so next question, I'm going to do a quick show hand in our audience. How many of you are using Service Mesh in production? Wow, that's totally surprising. Okay, very good. Good job. So the question I have for the panelists is, what are the scenario, what are the production usages you see of Service Mesh? Zach, do you mind go first?
Yeah, sure. I mean, so when we talk about Service Mesh, we kind of talk about these three pillars, right? So it provides visibility, observability, observability, traffic management, and security, right? And so we've seen real use cases that focus on each of those, right? The best way or the most successful way we see people adopt a service mesh is to pick a specific pain point, pick a specific use case, and use the mesh to solve that. And then once you have that piece of infrastructure there, it tends to balloon out, right? Because you now have this centralized control, you can now start to onboard these other teams to interact, right? So I've seen people adopt the mesh for each of those use cases, right? And it's more just what hurts most in the particular organization today, right? And part of that is which of the teams is the one funding this exercise as well, right? Because your central platform team has different pains than your security team. But once one of the team makes the investment, then you start to get these benefits of the centralized control, and they can pull in the other teams to start to benefit, right? And then you see the use cases expand.
I mean, maybe a couple concrete examples. So like one of the teams using Istio in IBM is our API management team. They built a product called API Connect, and their use case was more to kind of build on what you said. They started with observability. They have 170-ish microservices that they're running, and they put the service mesh in place to say, give us some better view of how these things are interacting and how they're behaving. And so, it's an interesting scale, a couple hundred services, that's hard to manage, and Istio helped them get that view. And then their kind of next step was, all right, now we want to turn on security. We want to turn on automatic encryption of all the communications and service-to-service authentication and authorization. I mean, another example, we have a client called Steelhouse. They do digital advertising. They're using Istio. They're more like 30-ish microservices that they're running in the mesh, so not huge, not two, but not a giant number. I think for them it was more about control of traffic, performance, and resiliency. Like maybe a third of those services are internet-facing, so they're in advertising, so latency and performance are super important in their business, and so they're using Istio to help them have better resiliency and control over those things. Right, just two examples.
That's a great example. Do you have anything to add, William?
Yeah, sorry, I was just trying to pull up the list because we have a couple LinkerD prod users talking at KubeCon. So earlier today, unfortunately, we missed this one. So, but someone from WePay, now part of Chase Bank, was talking about how they use LinkerD. The talk title is "Processing Billions of Dollars on GKE using LinkerD." And then we have there's another talk tomorrow from a startup called Just Football and how they use gRPC plus LinkerD in production. And then finally, I think there's oh no, sorry, there's two more. Sorry, I'll just mention them briefly. So Leo Lang is going to talk about meshing from monolith to microservices with LinkerD. I believe that was at OfferUp. And then there's a really interesting talk from Solt at VTT, which is a Finnish technology organization building cloud-native GDPR-friendly systems for data collection. So there's like a wide variety of uses, and I think, like to Zach's point, it really depends on what the starting approach is and what that immediate pain point is, and then from there, you can expand a bit. But yeah, we really see a very wide variety.
That's great. All right, so I would like to open up for you guys to ask questions if you guys have any.
So for each of the service meshes that you guys have used, which ones would be the use cases that you would definitely say, you know what, don't use this one because this one won't solve your problem? I mean, for each of the ones, what use cases wouldn't work?
You are asking a whole bunch of service mesh implementers that question. Just want to point that out.
Yeah. It solves all problems.
Yeah, it solves everything.
Yes.
Yeah.
I would certainly recommend that people try, right, the various service mesh implementations and see which one they feel comfortable with. Obviously, think about your use cases and look at the features that the products present, and make your own assessments. You go talk to people. I wouldn't get up here and claim that Istio solves world hunger, and I clearly shouldn't do that. And LinkerD is a good product built by good people, and you should evaluate their stuff.
Causes world hunger.
I think there have been, the projects have had different focuses over different periods of time. I think, on a common set of use cases, we're pretty convergent. So, you make your own assessments. Yeah.
So I'd add, not like one mesh implementation versus the other, but I do think, the architectures that we're putting in place with service meshes and with Sidecar architectures do add a small amount of path latency. For most applications, completely insignificant amount, but if the application you're going to run on a mesh is incredibly sensitive to path latency and extra hops, that might be a place where you at least test whether the service mesh is the right architecture, because you're adding, 8 millisecond-ish hops in between services. That's one maybe concrete case where, go into it with your eyes open. Right?
And it's probably also worth pointing out that there are kind of soft landings in between service mesh and not service mesh. For instance, one of the things on the gRPC roadmap is to support some of the same control plane APIs so that they can use that for service discovery and load balancing and credential loading, and interoperate with other things that are in a service mesh or behind a proxy, right, that is conforming to the same set of standards.
Another example is just deploying a Sidecar Envoy with a static set of configuration, right? You can actually wire up an Envoy to do pass-through things. You can get a lot of visibility. You can get some of the resiliency. You don't have the active control, but that's like a reasonable path that gets you. Again, it depends on what your paid is, right?
Yeah. Do you want to add anything, William?
Yeah, to Louis' point, like the beauty of open source is that you can try these things and you can come up with very concrete answer for what exactly you're going to get and what exactly you're going to, you're going to have to give in order to do this. So, read the blog post if you want to read the blog post, but nothing beats actually trying to get it working. And from the LinkerD side, the stuff that we have focused on primarily has been, I think, on operational overhead, on minimizing that at the expense of features. So there's a whole set of features that LinkerD doesn't have, at least not now. At some point, we'll have every possible feature in the world, but if you need something today, you're making a trade-off between, what are the feature sets and what am I going to pay to get there? And I think if you actually start experimenting, you'll get a pretty concrete sense of what that trade-off is like.
Okay, great. Does that help? Let's take one question from the back. Is there anybody who wants to ask a question from the back? Okay, if not, we'll take one question from the middle then.
Oh, thank you. So my question is, I know LinkedIn is a new service mesh implementation, as well Istio is some longer than it, and Google had invested in LinkedIn, both LinkedIn and Istio. For Istio, it's the founder together with IBM, and LinkedIn is also invested a lot. So I want to know, from Google's point of view, what your bet for these two service mesh technology, which your focus in the future for these two different service mesh technology.
Between LinkerD and Istio?
Yeah.
What Google is going to invest in?
Yeah.
Istio.
Okay. So the reason?
So is there a difference? Do you want to explain the difference between Google as the company was Google venture capital? That may be where the confusion is.
Oh, sorry, that part? Well, I wasn't involved in the discussion or the investment of Google X, right? You should probably talk about that.
Well, I didn't quite catch the question. Yeah. What was...
I think her question was mainly around Google is a heavy investor in Istio. As everybody knows, Google is a co-founder of Istio, major contributor to the project. And then her question was also, there was a blog about LinkedIn secure $10 million from Google venture capital. Which horse is Google betting on?
Yeah, okay, I get it, yeah. Yeah, so I can talk about that. So let's see, where do I start? Okay, so LinkerD is a CNCF project. One of the, I'd say probably the primary contributor to LinkerD at this point is a company called Buoyant, which I'm also the CEO of, so I happen to know kind of both sides, and I wear both hats. I wear the LinkerD maintainer hat and the Buoyant CEO hat. So now I'm going to take off my LinkerD maintainer hat, and I'm going to put on my Buoyant CEO hat. Buoyant raised some money, I think you said 10 million, which is right, from Google Ventures in order to continue developing LinkerD. Google Ventures is not a strategic investment arm of Google. They're a separate entity. They happen to have the letter G in their name. They're now GV. They're not Google Ventures anymore. They're GV. They have the G for effectively historical reasons. So they made an investment decision based on kind of the same things you would expect any investor to make an investment decision on. Yeah.
All right, let's take one more question.
Yeah, LinkerD was awesome. That's why they gave us all this money.
We like to hedge, right? Come on.
Hi. So question is about site proxies and its performance, and if you have an idea that site proxies should be something is the right paradigm, and what are your thoughts about improving the latency of sidecars?
Do you want to go, Zack?
Yeah. So I think one of the things that so sidecar performance is critical, right? And Louis mentioned, there are, for many applications, the latency overhead that a sidecar adds or the performance cost of a sidecar is pretty irrelevant compared to the application itself, right? If I'm
doors are now open. Please make your way to Hall 6. Across
Don't go anywhere. Everyone stay here.
Is that you, God?
We still have 15 minutes
Can somebody
with
close
our
the doors in the
session.
back?
But yeah, so the quick answer here is that, so it adds overhead for a large class of applications that doesn't matter. For applications where it does, a variety of options are being developed, right? So we'll see the sidecar move into user space, right? We'll see user space IP stacks come along. More generally speaking, I believe that we'll see heterogeneous data planes in mesh deployments over time, right? And that's looking quite a bit further ahead, but the simple fact is that different application profiles require different data plane profiles, right? And there's really not two ways around that.
I mean, I guess what I would add is I think we're at the stage where we spend a lot of time looking at primitive performance of the componentry of the mesh itself. Because obviously, as people building meshes, we're trying to make that overhead as small as possible, both latency and CPU and memory demand. But if you look more realistically at your application, like, it really is irrelevant in most cases.
Yeah.
And
look, as an example, BookInfo, when you run it without a service mesh and when you run it with Istio and when you run it with LinkerD, the performance gets better with both of the service meshes versus not running it.
right.
And that's because of the connection management that both of the proxies implement for a variety of reasons, right? And so it's another one of those you kind of need to see with your applications to some extent as well.
Yeah. So I think in that way, we've been doing sidecar architecture as part of meshes for a while now. We all feel pretty confident that that's a good approach. It's the right trade-off on what you were after, William, I think, which is get it out of the application space and get it into the platform. And sidecars are a really nice way to do that. And I think for the majority of applications, the performance impact's not meaningful. Right.
Yeah, but thinking about it as a trade-off is exactly right. Like we've had folks who've brought LinkerD into production, and not even the new one, but like the old one that was on the JVM that had non-trivial latency, and they did it, and they didn't care about that, and they did it as a sidecar, and they didn't care about the memory consumption because, in this case, it allowed them to get a consistent layer of mutual TLS in between all their applications. And the alternative to doing that was having to talk to every developer team of every service and get a TLS like work item on their roadmap, and that was basically an impossible task. And so in that case, that trade-off made sense to them. And it was a trade-off. They were exchanging kind of computers having to do more work with the organization as a whole being more efficient. And I think that's what is really interesting about the adoption of the service mesh is, yes, you're paying a computational cost for doing stuff, right? The sidecar model, by its very nature is like, we're going to add proxies everywhere, and then we have to talk, and it's going through the network stack, and like maybe we can do cool stuff and like reduce the cost, and we should try and reduce the cost, but you're always going to pay a price, right? So it makes sense in situations where you're getting a lot of organizational value. And the computers have to do some more work, but computers don't have feelings.
So when I was at Google, we would talk about, the resource that we would use is software engineering gear, right? And you can cost cores in that, and you can cost features in that. And that gives you a nice way to compare exactly those style trade-offs, right?
But what price human suffering?
Let's take the next question.
Yeah, so I was wondering about patterns or tips you might have for people who are moving services subsequently onto Kubernetes, but who might still have some legacy services running on-premise, because the features you might look at in a service mesh are very different when you only compare them for services running on Kubernetes as if you want to take others into account. And maybe there are certain patterns that you encountered in the world that might help with this endeavor, even just completely ruling out on-prem.
Louis, you want to take that?
Yeah, so I mean, I think LinkerD provides support for making sure that workloads that run on VMs, not just in Kubernetes, can be involved in the mesh, and Istio does the same thing. Obviously, Kubernetes simplifies the kind of operational aspects of kind of enrolling workloads into the mesh. Obviously, there's a lot more diversity out there when you're talking about arbitrary workloads running on VMs or bare metal. But that said, there's kind of two classes of issues that go along with bringing these things into the mesh. The first part is you want to get the common set of observability, control, and policy management. And in particular, a lot of those workloads are older, right, and tend to be less maintained or less amenable to change, and so your ability to get, say MTLS, like William's example, deployed into that infrastructure, right, you had no other way of doing it. You couldn't get the application team to go and change their code. The other thing that mesh provides is because it provides a higher level abstraction, it also provides a mechanism to kind of bridge networking issues across these types of deployments, right? Because, let's say your VM is running on a private IP space on premise, and you have all your modern, shiny Kubernetes stuff running in a cloud, and they're not on the same network. You need to be able to route traffic, right? And the mesh provides abstractions and mechanisms that help you do that type of routing, right, with security end to end all the way through that system, even when it transits over the public internet or something like that, right? Well, that's one of the, one of the key advantages of MTLS is you can use it not just as a, as a means to achieve a kind of point-to-point micro, VPN, right, and get all the security properties, but it can also act as a routing mechanism, right, because SNI is available at, edge points in that network, and these proxies can use that to do load balancing and make routing decisions without introspecting deeply into the traffic, which is a nice property.
Yeah.
I mean, I would add maybe just two other thoughts. I mean, I think Louis talked about the idea of kind of taking the mesh and extending it into the existing workloads, which both meshes do. I think Istio has also done some interesting work with ingress-egress gateways and kind of having a structured way in and out of the mesh that I've seen be used by a lot of people to help them kind of take new things in the mesh, connect them to existing systems, and use the policy mechanisms of the mesh to simplify all the things in the mesh's access to that. So I think there's kind of two interesting, integration patterns with existing systems. The other thing which I've seen happen a few times, which I think is quite interesting, is people are starting to put systems like Istio in place to get visibility into the existing applications to help them understand the existing world and how it talks to itself, and use that information to help them refactor applications into Kubernetes or into microservices or whatever they're trying to do. And so to me, that's a non-obvious thing. Like when we started this service mesh journey, I wouldn't have predicted that one would be a use case, but it is.
Well, and it gives you exactly the tools that you need to start to decompose those services and transfer them, right?
Yeah, interesting perspective. Really, I don't want you guys overwhelmed on different scenarios. Definitely pick one scenario that's most important to you and start that with.
While we were walking around, there was an example we had a meetup yesterday, and somebody had written a plugin for Istio that captured DNS requests and converted those DNS requests into entries in our service registry, so that you kind of had this kind of adaptive documentation of the dependencies of workloads that you didn't really know what they were consuming, which is a kind of interesting take on it.
Yeah, it's really cool.
For William, what's the difference between LinkerD? No, sorry, I'll leave that one alone. On the observability side, observability in a cluster of many microservices can obviously create a really large stream of data that's basically impossible. You can't have someone sitting there watching it. And observability is going to also mean different things to different parts of your organization. What sort of thoughts around that do you have about making the observability useful to those different parts of your organization in a way that's not overwhelming?
William, do you want to start?
Oh man, you're really picking on me. Okay, so the question was, how do we make the observability from the service mesh useful to other parts of the organization?
Well, yeah, it's different for developers as it's going to be to your managers. They're going to want to see different things.
Yeah.
And how do you make it not overwhelming?
So what I think is interesting about the visibility that the service mesh can give you in terms of like telemetry data or observability, and it's a similar story actually for reliability and for security, the three pillars that Zack talked about, is it's not a complete solution. None of these, it's a complete solution, right? The service mesh is not going to solve all your security problems. It can be a part of it, and it's not going to solve all of your visibility problems. And in particular, because of the way that it works, a lot of and maybe this changes in the future, but for right now, largely we kind of treat the services themselves as black boxes, right? And we're looking at kind of these observed metrics around them. So okay, what's the success rate? What's the latency distribution and things like that. The thing that I think is really interesting is, and maybe this was kind of what you were alluding to in the previous question, was drawing the graph between the services. That dependency graph is something that's actually, I think, super interesting to the rest of the company. And it's not something that is really obvious from the code, and it's not something that can be effectively captured in a spreadsheet, because the moment you write it down, it changes, at least in any kind of fast-moving organization. And I think that there's a set of advanced use cases around that graph where you start looking at things like, for example, how chargeback, or like how's the finance department going to figure out whose budget it has to be charged for this really expensive service, even though it's used by all these 7 other services. So I think if you starting with a very simple, I can just give you the graph between services, you can start extending that out into other parts of the organization.
But yeah, business metrics tend to be not necessarily directly related to the operational metrics that a mesh typically generates. And to William's point, that is one of the key gaps, right? And it could be very, very challenging to try and deduce the correct business behavior from these operational metrics, right? So to some degree, that's not necessarily the problem that these particular metrics are trying to solve. Right, they're incredibly valuable. They can do things like build these graphs and give you deeper insight that is very valuable to more of the organization. But in terms of just the raw data itself, the goal is that it be operational, kind of because of the nature of how the mesh operates, right? Because it's a black box.
That's a better answer than mine. Take that one.
I would add maybe one other thing, which is, I think service meshes are kind of a new collection of primitives, like a new source of really interesting data that we didn't have before, and a new source of kind of controls over the environment we didn't have before. But there's a tremendous opportunity and space for tools above the mesh to leverage that, right? Yeah. And lots of monitoring tools are going to take this new source of data and give you those different views and insights. I think CI/CD tools, there's a huge space for them to take some of the route controls that exist in meshes and leverage it to do A/B testing and to do canary and to make them richer. And so part of it's just building the ecosystem on top. Yeah.
And I'll go so far as to say, because we've been implementing meshes, to me at least, actually the mesh now is kind of the boring part, and the things that you can do on top is really the interesting piece. Because you have this common set of data and this touch point, you can start to do really incredible things over top.
There's a really cool project called Flagger, which I love from the Weave folks, which will drive a canary or a blue-green deployment, look at the success rate of the new code, and if the success rate is dropping, then it'll roll it back. And that's a perfect example of how you can take these primitives provided by the service mesh. There's another really cool project I just stumbled across called KubeCost, which will give you a breakdown of what the cost, when you're running your stuff on GCP and you're getting these big bills, it'll break down exactly what the costs are, and it can tie into the service mesh, and it can say, hey, here's a cost per request. Here's how much it actually costs you to serve each API endpoint. And I think that kind of stuff is super cool.
That stuff is actually the fundamentally transformational stuff, by the way. When you can start to do the cost accounting in that way, and when you can start to attribute costs and things like that, that is a fundamental shift.
All we need is all of you to deploy service meshes, and then that'll all work.
Yeah, hurry.
Well, interesting perspective. I think we may only have time for one question. Who wants to be the very special last one?
What's the worst thing about the service mesh?
No, so there's the CPU blog post. What are Istio doing to reduce the CPU footprint overall? Are there any special things that you're going to do? So obviously there was the blog post about the CPU footprint benchmarking tests.
Which one?
The one that's all over Twitter.
Which one?
By, is it Michael? Michael?
Shopify.
Yeah, Shopify guy. Yeah, that's it. Are there any specific things that you can announce maybe that Istio are doing to help reduce that footprint?
We certainly have a roadmap that is aggressively trying to squeeze the CPU footprint down and the latency footprint down. There's some pretty largest changes went into the 1.1 release We turned off policy checking by default through the Mixer pipeline because most people weren't using it. They were using the RBAC feature, which was implemented in the data plane directly. We have some stuff in the works to squeeze down the cost of our Prometheus integration, which is used by most of the end users. And there were some, there have been a couple of talks. There was a talk today about Envoy extensibility and the use of WebAssembly as part of that, and that's something that we'll probably aggressively leverage to kind of put more features directly in the data plane and control them with the control plane and use that to squeeze down resource costing. So there's quite a large amount of stuff coming.
On the LinkerD side, we're pretty happy at this point with the memory footprint and overall with the latency, but I also think LinkerD CPU is too high. So and that is, I think, mostly just a matter of like we need to sit down and do some profiling and tuning. We've been so focused on like building out the core functionality, that now it's time to squeeze the grapefruit and get the juice out, or whatever the analogy is.
And while we have all told you that when you should look at the relative cost of the mesh to your applications, I as a benchmark think that meshes are an order of magnitude more expensive than they can be, and that optimization work just hasn't happened yet. Yeah. And that's not speculation, right? Based on work that we've done internally at Google with our internal mesh, we have a very good idea of what the costing and overhead should be in certain circumstances, and it's an engineering grind, right? You got to go after every CPU cycle, every cache line miss, right? Every pointless kernel call, right? To squeeze that down. And
there's a lot of profiling and a lot of looking at code.
It's a lot of engineer hours to just grind away at that. It just takes time.
I mean, the only thing to add is make sure you look at it in context, though. Like, remember, part of the reason we started to build meshes was to take functionality out of the applications that was getting built into every service and put it in the platform. So, like, how much would it cost you to do all that stuff in your application, right? Because that's really what I think you ultimately have to look at is if you're going to solve those problems somewhere, it's going to have a cost. And, a lot of people are solving it in inefficient ways in every application. Right?
And to William's earlier point, there is also the hidden human cost of having to implement those things.
Yeah, I mean that company that deployed like JVM LinkerD as a sidecar, like tens of thousands of servers, like they were really happy with the result, right? And it was not because it was particularly fast or low latency. It's because of what it allowed them to do.
Yeah, it's great to see so much focus on performance. Folks, we are out of time, so I want to take a moment to thank all the panelists to be here today.